Homework S1, question 3. In this question, we've got a table of information comparing thickness of playing tiles in playgrounds to the maximum height that a child could fall without injuring themselves. We are asked to state which of the two variables is the independent variable, giving a reason for your answer. Now, it's helpful to just kind of ask yourself which one depends on the other one and read it out in both cases and see which one makes more sense to you. Is the maximum height that you can fall without injury dependent on the thickness of the tile, or is the thickness of the tile dependent on how high you can fall without injuring yourself? That first one is the case. So that gives the maximum height as a dependent variable and thickness is the independent variable. So what we can then write, it's easier not to define what the independent variable is, but to define what the dependent variable is. So I would use the phrase, the maximum height you can fall without injury depends on the tile's thickness. The thickness can be controlled by the manufacturer. And the maximum height responds to the changes in tile thickness. Now that's quite a long answer, and hopefully it's an overkill answer, and the first sentence alone would have been enough. But sometimes exam questions have keywords that they like their respondents to get into the question, so giving a slightly longer answer, covering your bases by explaining it in two different ways, just gives you more chance of getting the mark there, so long as you don't write anything contradictory. In part B, we're given a regression equation. H equals 0.0206t plus 0.312, and we're asked to use that to calculate the maximum height for thicknesses of, first of all, 70 millimeters and second of all 120 millimeters. In both cases, we're asked to comment on the reliability of each of these estimates. So these are our values of t that we need to plug into the equation. So just use a calculator. H equals 0.0206 times 70 plus 0.312. And that gives a height of 1.754 meters. Now the reliability just depends on whether this value that we're plugging in is covered within the scope of our table or not. Our table of data ranges between a thickness of 20 millimeters and 100 millimeters, and so 70 is fitting within that gap. If you're making a prediction based on a value that is inside your table, that is called interpolation. Just using that word interpolating, or its opposite, is enough to get you the mark. So all we need to write is the estimate is likely to be reliable, as we are interpolating. If you can't remember which of the two words is which between interpolating and extrapolating, you can refer to the values themselves, and you could say that a thickness of 70 is within the range of values covered in our table. But if you do that, it's really important that you refer to the variable, that you do have to refer to thickness or 70 or t. You cannot just say it's reliable because it is within our range of data. And you can't also refer to the height being within our range of data. It has to be the independent variable, or our x variable, in this case t. In part 2, we need to do the same again, this time with a value of t of 120. So again, plugging into a calculator, h equals 0.0206 times 120 plus 0.312, and that is equal to 2.784 meters. This time 120 is outside of our range of data because 100 was the largest value that we had. And that means that the estimate is likely to be unreliable. And the keyword that we can use to describe this is extrapolating. So as we are extrapolating. And if you use the keywords, those are all that you need to do to give those answers. Now in this case, 120 isn't exactly far off of 100, especially as we're going up by 20. It would probably have been the next measurement that you've done. And in some cases, you can get away by saying it might be likely because we're not that far outside the range of values. Personally though, I prefer to keep it safe and just say that if we're inside the range, we're interpolating. If we're outside the range, we're extrapolating. Now in the new course, the regression line is always given to you. Under the old course, the regression line would have to be found, and plenty of people would put answers about the reliability either based on the context of the question or quite commonly based on how well they thought they had done in finding the regression line. So a lot of people have put things like, I don't believe my answer is reliable because I think I made a mistake in part A. That sort of thing will not get you the mark. Amusing as it is, it's all about these keywords interpolating or extrapolating. Now in part C, a further experiment has been done where the manufacturer tests a tile with a thickness of 200 millimeters, which is way outside our table, but it's not making an estimate, it's actually doing a measurement. And they found that the corresponding height is 2.96 meters. We're asked to talk about the relationship between the tile thickness and a maximum height. Now our assumption has been that this is a linear relationship, and that's why we came up with the regression line in part B. Not we, the question. We need to check whether this relationship is still appropriate. So use that regression line and see what the model is predicting that we actually get as a maximum height that you can fall from. In this case, again, on a calculator, h equals 0.0206 times 200 plus 0.312, and that is equal to 4.432 meters. So our model is predicting that you can fall from a height of nearly 4.5 meters onto a tile that is 20 centimeters thick, and you'd be fine from injury. Their experiment showed that that's actually under 3 meters, so our estimate is quite a way out from what the reality is actually shown. We need to comment on that. This value is well above the actual observed value. The actual observed measurement. So we need to comment on what that means. Now we don't know for certain, so we've got a couple of things that we could actually do. The one that I would go for is that this suggests that the model breaks down for larger tile thicknesses. So what this means is that there eventually just comes a point where it doesn't really matter how much more the tile thickness is. You can't fall from that high a height. Eventually there comes to a cut-off point where this is as thick as it's going to go. It's about as safe as it's going to get. And if you fall from a higher height, it doesn't matter how thick your tile is. You're still going to hurt yourself. It could be that it follows a linear pattern for the early part, but ultimately it's a non-linear relationship, and so it started off on the kind of flatter part of the curve and then started to raise. We just need to give a credible reason for what this could be. As I say, this is the one that I prefer. I don't want to speculate on what the actual relationship is. I'm just saying that it works for smaller values, but eventually there comes a point where it just stops working, and that's not appropriate. This works really well on models that are talking about age and development, where a model could work for juvenile things that you're measuring, be that people or animals. Eventually there comes a point where you stop growing, you stop changing, and it doesn't apply for adults anymore.